everybody, my name is Lucas, and today we are going to talk about Zod, right? So let's get to the chase here. I'm going to put here our presentation. And before I start talking about Zod with you, I'm going to present myself, right? So my name is Lucas Santos. I am originally from Brazil. Today I live here in Sweden, and I'm one of the senior software engineers at Klarna, right? You can reach out to me on any of the social networks I have over here. So just like twitter.lsantos.dev, github.lsantos.dev, anything that you want, .lsantos.dev, right? You can see most of my content. Some of this content is in English, some of this content is in Portuguese, but I always produce content. So I'm doing videos, I'm doing blog posts about basically everything, mostly TypeScript and JavaScript, but I do write about Docker, infrastructure, and everything else, right? So I am one of the Google developer experts, Microsoft MVPs, and Docker captains. And if you want to know more or anything about me, or if you want to ask any questions, I'm always free and I'm always open for anything, right? So first off, let's talk about Zod. So Zod is a schema validation library. So it's a TypeScript first schema validation library. It allows you to declare schemas and also to validate your data against it. And schema validation is one of the most important aspects of any application because it allows you to be consistent in your data. So it guarantees that your data is always going to be the one that you're expecting it to be, especially in TypeScript, right? So let's see how it kind of looks like. Let's see how it kind of looks like here. So Zod, it's pretty simple. It's easier to read than most of the things. You can already see that it's something like we had before with Joy and other things, like other very good APIs, to be honest. So the big difference on Zod is that it is TypeScript first, so you don't have to type that data again. As you can see here, our schemas, you can actually see it, but it's already typed in. So it's defined on concepts like Zod types. So you can see that this is a Zod string, and this is another Zod string, but this is also a branded type. So Zod supports very important and very complex types like branded type, discriminated unions. It has transformers, custom validations. It also has built-in validators like UID, dates, emails, URLs, and a lot of other stuff. And the good thing is that everything else that you create in this schema is going to be transferred and converted into a TypeScript type, so you don't have to type it all again, right? So how does it looks like, right, in this case? But Zod is not the first thing. So we have other libraries like AJV. AJV is, I think, one of the oldest ones, and it's basically JSON schema, right? So JSON schema is a classic thing. It doesn't create a type-safe validation because it's basically an object, and then, well, there is no types. It's quite verbose to define. Even if you have like a big schema, it's very difficult, and it's not very easy to work with. It's quite old, it's not very maintained. We do have a few other types, like with typeox, for instance. It's another type like we have here. So typeox is another library that we can use to generate JSON schema from our types from TypeScript, right? So basically, if we want to use AJV, we want to add types, we can use typeox, so we can add JSON, we can create JSON schemas from our types. The problems remain though. We still need to, parse that JSON schema into something else. So plus it's two tools difference and two libraries, like libraries that you're going to use, and well, another thing to worry about. Zod is also not the third one. So this one is a classic. The most classical one is Joy. So Joy, as you can see, was very inspirational for Zod. We have this almost the same API. So you can see Joy object, Joy strings, and you can put like this fluent interface. It's, to be honest, one of the best that we use. It's one of the closest to Zod that we have today. The thing is that it doesn't produce type annotations. So you have to define your types in the same place. And actually, you have to define your types differently from your schemas, which can create very different and very complicated problems for you when you're maintaining your code. Then we have another library, which is IOTS. It's not even the fourth. But I put Zod website here. As you can see, there's a lot of other things. But in the end of the website, we have this comparison with IOTS here. And the idea of IOTS is to be functional programming first library. So it's very, very composable. It's a functional approach to schema validation, and it's good, but it's very complex to read, and it's complex to write, it's complex to understand, and even more complex to give maintenance. Like for this, let's give it an example. Like this example is like creating an optional type. So to create an optional type, like an object with one key that's not optional and one key that's optional, we have to create a type A, which is required. Then we have to create a type B, which is a partial type. And then we have to intersect both type A and type B into type C. And then this will create an object which will have a key, an optional key, and a required key, like the one we're seeing here. Like we have a foo, string, and a bar, which is an optional type of number or undefined. So it's quite complex. We used it a while at Clarion as well, but it's very difficult to maintain, and it has a lot of different names for everything. It allows you to do a lot of stuff, but it also needs you to create a lot of boilerplate and other function code to make it easier to work with. But we also have another contender. Like we have, Zod is not even the fifth. Actually, Zod came before archetype, but archetype is another thing. It's a very, very nice library. It's a new kid on the block here. It allows you to create types from a mix of Zod and IOTS, but it's still not that easy to read, and it's not very easy to understand because it's not consistent. Sometimes you can create using just TypeScript types, but you can also create using strings, like you want to see here. Like you can replace basically everything here and create like expressions. You can put arrays, but you can also put normal strings. So it's quite difficult to understand. It's basically another language that you will be dealing with. So, but it's not a bad one. It's very good as well. We tried as well, but we didn't like it very much. Well, then why do we need Zod if we have 5 other things that we can use, right? So first off, AJV and typeox, they're not TypeScript first. So basically they rely on JSON schema, which is not bad, but they're long, they're verbose, and they're difficult to read if you have a very, very long schema. And plus, they don't produce types. So you have to define your types or use typeox, for instance, to create another type of your schema, while these schemas should be producing those types. Joy is not TypeScript first, doesn't produce types. It's quite old, not very composable, and it's also not super maintained. It has like contributors, but it's quite old. It's a quite old library. ILTS is super composable. I think it's one of the most composable ones we have here. It's also super complex. So it's not very easy to read or maintain. So in the long run, it's not very interesting. And archetype's a new one. It's good, not as mature as Zod. Plus, it's also not as easy to read or maintain, like I explained before. So Zod solves all those issues in a way that it's its own way. So basically, Zod, it's built on top of the concept of Zod types. So Zod types are basically their own schema. So Zod string is a schema on its own that you can use to validate anything. You can use those schemas to compose other schemas, bigger schemas like Zod objects with Zod strings inside and stuff like this. So you can compose those schemas, which are also standalone, but they work very well in group. Then you can compose those Zod types, like I said, into more complex schemas, and you can transform or refine or even extend your schema with custom validation. So like if you want to extend your schema, you want like you have a user and another type that it's basically the same as the user, but with 1 or 2 extra fields, you can just take the user and extend that type. You can actually take parts of one schema and add into another, because all those types are interoperable. So you can actually use them in a very, very good way. So it's basically made to be extended. It's made to be transformed and refined. It's a very good library to handle errors, especially in APIs, because it has a very, very good messaging system. It's very focused on completeness and clarity. So it shows you what is wrong, where is wrong, what you need to do to fix it. So you don't even need to, you can actually standardize, like I'm going to show you in the end, all the errors into Zod errors. So all these things make it easy to read and maintain. So your team and your application is gonna give you like a pat in the back because it's very, very easy. It generates the types for you, so you don't have to create types from your schemas, and you have to maintain two things in separate places. And it has support for advanced features like random types, unions, discriminated unions, enums, even native enums, and more, right? So let's compare Zod here. We have the same type using joy. So basically, we're just defining our object here with an alphanumeric and everything else, password, joy string with is required. And then we validate using defined and object that we're passing in. What this is going to do is going to give us some errors or some success according to what we are giving it, right? But if we look at the types, we are going to have any's. And joy doesn't type anything unless you really want to type it. You can actually do generics in the objects and stuff that joy gives you, but basically you have to maintain both the generics and the schemas, which is not very good. And when you have to type it yourself, it means that we have two sources of truth. We have a source of truth that is the schema and another one that is the type, and they're not connected, which means that if you change one, you have to change the other. The one, they don't talk with each other. And this is very error prone in a sense, right? So how can we make it better? So the Zod way of doing it is basically that this is the same thing. We have a username, which is a string. It has a minimum of 3, a maximum of 30. So everything in Zod is required by default. So we just define the schema over here. We don't have to put like if it's required or only if it's optional. And then we have a password, which is just a string. And then when we parse that schema, you can see that it already gives us a variable that is typed as the schema. So you can see that in the constant here, we already have like the user with a username and password, right? So we basically have everything that we need. And then we can infer those types by having the completions and everything else. We have Zod infer, which is another thing that I'm going to show you soon enough. But because of this, we already have completions for everything. And well, types and schema are now agreeing. And then we have a change in the schema, which will produce a change in the type, which is now instant feedback if you want to. So it's basically the best thing if you want to do it, because you are guaranteeing both compile time and runtime security of your types with Zod, right? So there's one thing that we take from this, which is schema-driven development. Schema-driven development is actually a word that we came up at Klarna, and I've been using this for a while. It's just naming things. But the idea is that it's when you focus your data only on schemas. So everything that you have is defined on schemas and in one single place. So let's say you have an API. Every data that comes in the API is defined in a schema that is in one single place. So every data that you go through in your API or your application, both outside, inside, or anything that you movement that you move from one to the other, it is based on the schemas, right? So the schema is the source of the data, and it allows your application to stay consistent because you can just validate every data that you have, every piece of data that you receive, you can validate against those schemas. And if it's not correct, basically it's going to throw an error. So you always have the certainty that you're going to have that specific data at that specific point in time. So this reduces the sheer amount of errors, actually reduces a lot the amount of errors, and makes your code way more readable. Because if you change a schema, let's say your API changed, your user changed, or your requirements have changed. When this happens, you have a change of schema. And when the schema changes, what you have to do is actually to change the types, right? Because if you have an input data that is different from the one they're expecting, you have the types that have to validate that data. And when you have a schema-driven development, you don't need to do it by yourself because you define in your schema, and your schema is connected to your types. So if you change your schema, your types are automatically going to change. And if something goes wrong, you already have instant feedback on the build type. So there are some rules from schema-driven development. The first one is that the schemas are the source of truth. So trust the schema only, right? It will generate a type for you. You don't do the opposite. You don't generate a type and then create a schema based on the type. You generate a schema and then the types generated from that schema, right? Types should always be a side effect of a schema, right? The next one is a dry principle. Never duplicate, don't repeat yourself, right? So never duplicate. If you need to use the same type, or even you need to extend or use the same parts of a schema, either extend or reference the new schema. Do not recreate. Always validate and never cast. So this means that never cast a schema into a type, even though the schema is wrong, or even though the schema is producing something that you don't want to, don't cast it into a type. Always use the schema to transform your input data into your output data without changing those types. So transforming the source into the final object in schemas, precisely in the schema. I'm going to show you this in transforms and refiners in later on. But make use of type guards and type assertions if you want to cast one thing into another. But the idea is that you should always parse the data and never just directly cast it. Then the next one is the principle that the data flows in one direction only, which is from outside to the inside of your application. So if you think of an API, the outside is the outside world, the ones that interacting with your application layer, your presentation layer, so your clients. They are sending data in, and then this data comes from the outside, passes through your validations, and then goes inside. Sometimes if you want to take this into another level, if you have like a data layer, or if you have a service layer, let's say you're using MVC, for instance, a model view controller layer, when you pass data from one layer to the other, you can also validate, because this defines like, okay, this is an outside of my layer, and you can both validate it and cast it to be a correct type all times, right? So this creates a lot of security. So the first thing, let's go a bit deeper into these rules. Never redefine a type that can be inferred from a schema. So if the type changes, if the schema changes, your type will not follow. So let's say, don't do this, like you have a schema here, and then you duplicate it by defining an interface. So if the schema changes, the interface is not going to change, or if the interface changes, the schema is not going to change. So you have a mismatch. What you need to do is to define your user schema, and then you use the infer, for instance, in Zod, that is going to give you a user type. And if you change your schema, like if you change, let's say, the pass for string to number, the new pass on the user type will be a number, right? So you already have this instant feedback. The next one is a very important thing. Data is not unique. We are very, very prone to believe that we always create new stuff. But how many times have you ever needed to type in an ID, an email, or an URL, or something like this, right? So data is not unique. Extend, reuse, do not recreate, okay? Do not recreate things that you can reuse from other schemas or other things, especially if they are the same. So you can extract those IDs, let's say IDs or emails or validations from your schemas to a specific Zod type, and then use it in all the schemas that you have. So if you change the validation in one place, it's going to change for everybody, right? So this two examples that we have, like we can either reuse one schema. So that's what I did here. Like we have an ID schema, and basically I define an ID, and the other one is the user schema that's using the ID schema for its IDs, right? So if you have let's say other entities that have the same IDs, it allows you to make the schema more concise. So it's basically the preferred way for primitives like IDs, dates, I don't know, emails, things like that, because you can add the validation to them and propagate the same validation to other systems. And the other one is to extend. So when you extend a schema, it's more important when you have like variations of the same idea. So in this case, we have a user schema and an employee schema. And every employee is also a user, but the employee has a badge number. And then we can extend the user schema having the same things that we had before, but adding the badge number on it as well. We can use a very specific property called shape in Zod. So user.userschema.shape, for instance, is going to give you the specific types on that schema if you want. So if you want to just take one of the options from this, like user schema.shape.id, and you can take that ID from one schema into the other. So let's talk about when Zod is actually not enough, when we can extend it, we can validate it. So if you need a custom validation, you can extend Zod and refine your data. You won't always have all the validations correctly set, and you need to create your own set of validations for your own business logic, for instance. Like with Zod, this is very easy because it allows you to do it in two ways, a refinement or a transform. So in this case, you see that we are defining our object here, right? So we have a very big configuration object. This is a very common example, actually, where we parse a configuration schema and we basically have an environment file to an internal object that we're going to use throughout our application. So in our environment file, we have everything separated, DB name, host, port, user, paths, everything. But then we can transform that configuration file to only have two properties. The port one that we're using, we have to convert it to a number. And we also can concatenate everything into a connection string in our database, for instance. And then when you parse the schema, I just passed a empty object. It's going to be an error for me, but not error because we have default. But if we parse the schema, it's going to give you a connection string. And you can actually return things from here as const, and it's going to give you a constant type, right? And then we have refine. Right, so refine is when you have to extend your validation to create your custom validator. So it's a function that just returns a Boolean and a message, right? So let's say that we are defining our schema here. We have a port, but the port has to be in the same range of a 16-bit integer, right? So we have to validate if it's above 65,000. So if it is, we just throw its invalid port range. We cannot use it. And notice that we are also transforming this into a number. So we are basically refining and transforming into a number, but the refine, it's not going to give you the transformation. So in the end, what we have here, so it's basically defining on the Z port, right? So when you're having like this logic, we are refining this this property here, right? Not the whole object, just this property. And then if you go further, you can see that in the end, we still have the port as an uppercase string and not a lowercase number because we're not using transform, right? And then we can just validate, and if it doesn't validate, it's going to give you a Zod error. But then we can transform and refine. We can do both of the things. It's actually one of the very common patterns from Zod. So transform is going to really transform the output into something else, while refine is not going to transform anything. It's just going to validate that it already have. So in this case, we're defining our object here, the same object, but then we're first refining the thing, right? So then when we refine everything, we can also transform that into a string, for instance, right? To a number in their case. So here in the transformation, we are doing two things. We are both transforming this into a lowercase string, right? So port as a lowercase, and then a number, which is the port number, right? And then in the end, when we infer, it's a bit different from the string that we had before, and it's also lowercase, right? The transforms can also be applied on a type level. Here on the other one, what we had was that we were applying this in an object level. So if we look at this, this is the object that we are actually defining. So we are defining the transform in the object and not the other way around. But if we go to the object level, the type level, we can apply the transform into the type, the port itself. So here we're just transforming that into a number first, and you can see it's still a string, the V is still a string. And then when we refine our P, it's a number already. And then we can validate if P is above the defined range. And then we can all do this at a type level, but then we can also transform the whole object, which is now a string, to give us a port number. In the end, we also want to talk about error handling, right? So how can we handle these Zod errors? So Zod has two methods, the parse and the which will try parse, and if it fails, it's going to throw a Zod error, and the save parse, which is basically the same, but it's going to return a schema. It's always going to return something with a success property and a data property. So you can use it to save parse. Both of them also have their async counterparts. And Zod error is a very powerful class that includes the error message, issues found in, and the schema, the path, everything that you have, and you can actually use it to validate everything. So this is one of the ideas that we use. So this is for the safe parse, right? So if you're safe parse parsing, you have success, false, and error, which is a Zod error. And if you have a true in the success, you have the data, which goes back for you, right? In an API, let's say, we can define our schema, then we have a route in here. We can just safe parse the schema that we're using, and then it's going to return a success or data and a data. And if it's not a success, Zod already knows that it has an error. So we can just throw a 422 with some processable entity, and then we can just do error.message, which is going to tell us if that the problem which is going to happen. And then if there's no error, we can just return the JSON after doing something in our API. You can also handle those errors in the unsafe mode. Like I like to call unsafe because we have try catches, but the idea here is that we're using parse instead of safe parse, and then we have try and catch. And then we just have to validate if the error is an instance of a Zod error. If it is, then we can just return that error as a validation error. And the Zod error is actually pretty complete. It returns a lot of properties. You can have invalid type, it's expected a string, receive the number and the path, so the path to your object, and the message that it's going to receive in the end. You can also format this. If you apply the format function, it's going to just condense everything into one place. And well, to finish the talk, I'm going to give you an example of a reality example. Let's not talk about the examples in a real case in Klarna. So as a bank, most of our systems interact with external providers like PSPs, and they're not synchronous, right? So some of them use webhooks to relay the responses to us. And some of those other internal systems even, they do the same. So when this happens, we end up with a very complex schema. So the idea is that sometimes they send us a JSON string, which is basically a huge object that's going to be inside the string, which is the data that we send to that webhook. So they're going to just send it back to us. And this is where Zod actually really shines on this. So these kinds of complex schemas, they're usually nested. So you have a schema inside a schema. And these contain a very important thing. So can you spot the problem in here if you have this schema? The most common type of this when we have a webhook is that they send this client data to us. The problem is that the client information that is sent through a string is not validated. It's not inferred. We lose the type inference from the client information, and we need this type to be validated at all times, right? So how can we do it? The first thing is that we can define our complex schema. So this is our client information schema. We just define it. It's everything that can go in that object. Then we can define this into a complex schema. So the complex schema, as you can see, like we can just define this schema into our own main schema, but we cannot just use the root. We're actually using the transform in the type here. So we're saying, okay, this is a Z string, but we want to transform this type after we receive it into a object. First, we're going to parse it. We're going to use try catch for this. First, we're going to try to parse a JSON. If it's an invalid JSON, then it's also an error. Then we are going to try to parse this JSON object into our own object, right? So we're going to do a try catch. If it's a Zod error, which means that the JSON is valid, but our own our validation is not valid, we can just call error.issues.for each and then add the issue to our context. This is one thing that you can do with transform. You can both validate and also parse your schemas, right? So if you don't want to use refine, because we would have to use refine and then transform on this, we can just add the issue. And once you call add issue, Zod is going to throw on this. It's not going to be validated, right? So if it's an instance of a Zod error, we're just going to add the issues that we already have from our Zod error previously into the one that we are already creating in the context. Otherwise, we're going to create one issue ourselves, and then this is when the JSON is invalid, right? So this is a fatal error, and this is going to return to us a never. So in the end, we're going to have a very complex schema that is completely typed and validated. So if the schema is not valid, it's either because of invalid JSON or invalid client information. It's going to throw us a Zod error with all the issues that we need. So in the final schema type that we have, we're going to have all the root objects that we have, like masked pen, order ID, authentication token, items, etc. But also we have inside our client information our validated object, and we can expect that this validated object will always be correct because we're always going to validate this, right? So in the summary, let's do a quick recap because I'm running out of time. But Zod provides a safe validation for objects and primitives. Zod is a validation library. It makes very easy to make your types consistent across your application and allows you to extract the types from schemas to other schemas, or even reuse those types. You don't need to type anything manually, right? Define your schemas in a single place, reuse them from there. Do not repeat yourself. Always remember, if you have to recreate, it's wrong. Try to extend or try to reference everything, right? Types come from schemas alone. You don't have to define your types and then your schemas. You have to define your schemas, and those schemas are going to produce types, not the other way around. Extend Zod to create custom validations and refine and transform and everything else. So you will need custom validations. This is normal for everybody. But if you are using Zod, that's pretty easy. Make extensive use of refine and transform to do it. You can use Zod error to type our APIs and parse the messages automatically. Zod error is actually a pretty consistent validation message, so you can just return it directly from your handler. You don't need to do a bunch of other things. If it's a Zod error, it's a validation error. You don't need to create anything else, right? And Zod really shines when you have complex schemas. So when you have complex schemas, try to break them down into different schemas and then parse them using transform, right? If you had another nested schema inside the nested schema, you could always transform the schemas and bubble them up, right? So this is what I had for you. I hope you really liked it. Thanks a lot for receiving me here. Again, if you want to reach out to me to anything, my socials are here in the bottom. So it's just the name of the social network, .lsantos.dev. And if you want to see this talk on my website, just scan this QR code or go to my website in there, and you can see basically most of my talks that are right? So thanks a lot for this presentation, and thanks a lot for watching me. See you soon.